everyone. Today we are going to see the application design grid connected inverter with DG simulation, which is our CI activity of power electronics subject. So let us see the simulation. So this is the main simulation, which is a block diagram. In this block diagram, we have the measurements block, in which the measurement is there, which is going to be explained by Shweta Thorat. After that, there is a DG set, that is a distributed generator set, from where we will get the source voltage. This is for inverter based distributed generator. It is a 3-phase AC power using controlled voltage sources. Then we have the line. This line is nothing but the simulated transmission line between DG and grid. It induces resistance and inductance. Now we have the PCC. So PCC is point of common controlling, or point of common coupling. So the node where DG connects to the main grid is nothing but the PCC. Then we have 3-phase AC sources. So these 3-phase AC sources represent the utility grid's 3-phase power supply. It helps to test the synchronous block monitors voltage, current and power. So this is all about it. In this, we can see there are the block diagrams in which the actual working and components are used. So now Kajal will continue with the DG set.
Thank you, Ayush. My name is Shweta Thorat and I'm explaining measurement blocks. So there are two blocks, top block and bottom block. So in top block we can see that input voltage grid and current voltage grid, and in bottom block we can see PV solar panel, input voltage PV and current PV. Both are use similar logic. They take the voltage and current as input process and then using subsystems. They are labeled with ABC or similar to it, and multiple send output to display and scope. And next we will see that it's performed like power measurement in 3-phase or in single-phase system, where subsystems are labeled with ABC or VA, VB, VC or IA, IB, IC. It's convert measurement voltage current into the instantaneous power components. It's obtained power measurement and blocks. Thank you. Next will be explained by Shiv.
Okay, thank you, Ayush. Now we are going to see the DG system. In this, we are going to deal with the block diagram, where we are going to see the control unit, control voltage source, then inverter, inductance, PV bus, and the load, and their purpose. So here we see the control unit. Control unit used to generate the signals, and the signal goes to the bus through to the voltage control source, and that source going to the inverter. We know the inverter use of inverter, which convert DC to AC, and that AC signals pulsating is pulsating AC signal goes to the PV bus, and that PV bus represent the connection points of DC source of PV panels, and that this signal is going to be load, which carries the AC signals, and the signal is provided going through the or provided to the load or the connection point, which is connection 4, connection 5 and connection 6, and this connection represent the local load connected to the DG. Thank you. Then Shivam will continue.
Thank you, Kajal. Hey everyone, my name is Shivam and today I'll be explaining control unit of the Simulink model. So this Simulink model represents a closed loop control system. It is for power electronics converter such as DC to DC converter. This system adjusts its output voltage current by comparing with the reference and regulating switching elements. So there are main sections that are reference and feedback path, control logic and PI controller. First, for reference and feedback path, the upper section has blocks labeled as reference input, VREF and QREF, which is VREF is a active power, active voltage, voltage reference, and Q is a reactive power taken as a reference. Then feedback is has voltage output and current output. These signals are compared using a subtraction block to get an error signal. This error represents the difference between desired and actual performance. Second is control logic or PI controller, where the middle part includes gain, summation and integrator blocks, which gives us the output. Then together they form a proportional integral controller. The proportional path reacts instantly to error. Then the integral path accumulates past errors to eliminate steady state offset. So the output from this controller generates a control signal. Then third is the PWM general line switching. On the right side, a PWM pulse width modulation block is visible. The it is the triangle or sawtooth generator plus comparator system. Then the control signal is compared with a carrier waveform to produce gate pulses. These pulses are sent to power switches like MOSFETs, IGBTs in the converter in a converter system. Next, we will see the waveform of the system.